Hello guys, welcome all to SnapSolve. I'm Shivam Patel and you are watching my class at SnapSolve channel. So, if you're new to this channel, please subscribe to SnapSolve and hit the bell icon so that you can get notified every time we upload a video. So, what we studied in last class? See, in last class, we were studying about momentum and we studied about first law of motion, right? So in today's class, we are going to move further to second law of motion, right? So I guess all the doubts regarding the momentum of the body, how we calculate the change in momentum were clear, right? So if you are having any doubts regarding these things, please keep on commenting. I'll be here to clear your doubts. Okay, so let's move further. The topic today is second law of motion. Now, please tell me this thing that how many of you think that F is equal to ma is second law of motion? Please comment fast. How many of you think that this is the second law of motion? I'm waiting for your reply. Like I have heard so many students telling this to me that when I ask them what is the second law of motion, what they tell me is that F is equal to ma is the second law of motion. But in reality, this is the result of the second law of motion. This is not the second law of motion, right? So what exactly second law of motion states? Now, according to second law of motion, the net force acting on an object is equal to the rate of change of momentum. Is it clear to all? Let me write the statement first. According to second law of motion, the net force acting on an object is equal to rate of change of its momentum. Clear? Very simple statement, right? So let me write the numerical form of the statement. If you are having any doubts, please keep on commenting, right? First, tell me who all are present here. Just raise your hand. Fine. So let's say that there is a body of mass m which is moving with initial velocity of u meter per second, right? We applied a force F over it, and after some time, because of application of this force, let's say the velocity of this body became v meter per second in time duration of delta t seconds, right? So, what is the initial momentum of this body? The initial momentum of the body, as we know, what is momentum? Momentum is mass into velocity, right? So, the initial momentum of the body is mass into initial velocity u. The final momentum of the body will be mass into final velocity v, right? So according to the statement of second law of motion, which says net force acting on an object is equal to rate of change of its momentum, right? And please remember that the net force will include the summation of all the forces. I'm talking about the vector sum of all the forces acting, right? That's why the term net force. So see how the statement will look like. We'll write F net, and this will be equal to rate of change of momentum. Now, whenever we are talking about rate of change of something, that means how much is the change happening in 1 second, right? Or we simply divide it by delta t. So change in momentum is delta p divided by delta t. This is actually the rate of change of momentum. Am I visible and audible to all of you? Please tell me, right? So see, the change in momentum on the top, you can write it as final momentum minus initial momentum divided by delta t, right? In case of final momentum, we can write mass into final velocity, this thing, and in place of initial momentum, you can write mass into initial velocity u divided by delta t. Now see, if I take m common from this, this will become v minus u divided by delta t. Now tell me, what is this thing in the bracket? This thing in the bracket. What is this thing? V minus u by delta t. This thing is acceleration of the body, isn't it? What is the formula for acceleration? Acceleration was defined as rate of change of velocity per unit time. So in this case, v minus u by delta t can be written as mass, this thing m as such, and this thing is equal to a. right? So this result we are getting F net is equal to mass into acceleration. And please remember, force is a vector, acceleration is also a vector, and we can write that the direction of acceleration vector will be same as that of the force vector. So this is the result of second law of motion, not the second law of motion. So whenever you are asked to write the statement for second law of motion, please don't write that net force acting on an object is equal to mass into acceleration. Right? It is the net force acting on an object is equal to the rate of change of its momentum. Is it clear to all of you? Is my video okay? This is on, right? Please comment and tell me, am I visible? Okay, I'm visible here. ठीक है, cool. So, okay. So let's move on to the third law of motion, which you have studied numerous times in your past, right? Starting from your sixth class, you're studying this third law of motion, right? So let's move on to the third law of motion, which states every force has an equal and opposite reaction, right? So suppose two people are fighting with each other. If I applied, suppose I'm fighting with someone, let's not fight, but still, suppose I applied a force of 5 Newton on the second object. Now, according to Newton's third law of motion, the second object will also apply the same force on me in opposite direction. That is called the reaction force if you are taking my force as the action, right? And one more very important thing regarding this thing is that these two action and reaction forces, they act simultaneously on different objects. Like it's not going to happen that I applied a force of 5 Newton right now and the second object will apply the 5 Newton force on me after some duration of time. These forces will act simultaneously. So are these points clear to all of you? Let me write the statement first. According to third law of motion, every action has equal and opposite reaction, right? And what are the important points regarding this? You should note down this thing that the action reaction forces act on different bodies, right? So let me make a note of it. Action and reaction forces. Please tell me if you're having any doubt. Act on different bodies, right? And the other important thing which you should note down is that they are simultaneous, right? These forces will act simultaneously. Clear? So these forces will act simultaneously. That means at the same time. Ranjit Singh is asking, sir, Hindi mein. Okay, just a minute. At the same time. ठीक है भाई, हिंदी में भी समझा देता हूं. देखो, न्यूटन्स थर्ड लॉ ऑफ मोशन सबने पढ़ा है. ये कहता है कि एवरी एक्शन हैज एन इक्वल एंड अपोजिट रिएक्शन. आपने अगर किसी पे फोर्स लगाया है तो वो ऑब्जेक्ट भी आप पे इक्वल एंड अपोजिट फोर्स लगाएगा, राइट? एंड ऐसा नहीं होगा कि मैंने किसी पे अभी फोर्स लगाया तो उधर से फोर्स थोड़ी देर बाद आएगा. ये एक साथ ही लगता है, ठीक है ना? एंड डिफरेंट बॉडीज पे लगेगा. एक्शन रिएक्शन अलग अलग बॉडीज पे लगता है, राइट? सो कुछ एग्जांपल्स देखेंगे, थोड़ा समझ आ जाएगा. उससे पहले लेट्स टॉक अबाउट द फ्री बॉडी डायग्राम. व्हाट डू वी मीन बाय फ्री बॉडी डायग्राम? दिस इज अ वेरी इंपॉर्टेंट टॉपिक, राइट? So देखो, suppose we are having a system in which there are so many bodies, right? And each of these bodies are applying force on each other, right? So when we talk about free body diagram of an object, what we mean is you put that object aside where no other object you have to draw, right? And just apply all the forces or mark all the forces which are getting applied on the body. So in Hindi you can simply say it. Suppose आपके पास एक system of bodies है जहां बहुत सारे objects रखे हुए हैं, right? हर object दूसरे object पे force लगा रहा होगा. तो आपको क्या करना है, किसी एक पार्टिकुलर बॉडी का अगर फ्री बॉडी डायग्राम बनाना है तो आप क्या करेंगे, उस बॉडी पे जो भी फोर्सेस लग रहे होंगे, राइट, वो आपको मार्क कर देना है यूजिंग एरोस। तो ये बन जाएगा आपका फ्री बॉडी डायग्राम। समझ आया? कुछ एग्जांपल्स देखेंगे, देन ऑल द थिंग्स विल गेट क्लियर टू यू, राइट। तो यहाँ पे मैं बस यहाँ पे लिख देता हूं व्हाट इज फ्री बॉडी डायग्राम। सो फ्री बॉडी डायग्राम में क्या करना है आपको? जस्ट मार्क ऑल द फोर्सेस एक्टिंग ऑन अ बॉडी। ठीक है, प्लीज रिमेंबर, आपको वो फोर्सेस मार्क नहीं करने हैं जो बॉडी दूसरों पे लगा रहा है, राइट। You have to mark only those forces which are getting applied on the body, not those forces which the body is applying। ठीक है, ये क्लियर हुआ कि नहीं हुआ, जल्दी से बताओ। थोड़े से एग्जांपल्स देखेंगे तो आपको समझ आ जाएगा। फ्री बॉडी डायग्राम के एग्जांपल्स देखने से पहले हम बात करेंगे इक्विलिब्रियम ऑफ पार्टिकल की, राइट। व्हाट डू वी मीन बाय इक्विलिब्रियम ऑफ अ पार्टिकल, right? So when we talk about that a particular system or a body is at equilibrium, we actually mean that there are two types of equilibrium, right? So let me mention these two things. There are two types of equilibrium, दो तरीके के equilibrium होते हैं। एक होता है translatory equilibrium, right? And the second one is rotational equilibrium, राइट। तो इसको एग्जांपल से आप ज्यादा अच्छे से समझ सकते हैं। लेट्स सी, लेट्स से दैट देयर इज एन ऑब्जेक्ट। यहाँ पे एक ऑब्जेक्ट रखा हुआ है, ठीक है। Let's say we have this object placed here on the ground, and there are two persons who are applying force. Let's say this person A is applying a force of let's say 5 Newton from this side, and another person B is applying a force of 5 Newton from this side. So what is the net force acting? Yes, good afternoon, Anika. What is the net force acting on this object? Please tell me. What is the net force acting on this object? Will this object move? First, tell me this thing. Assume that the surface is frictionless, right? Will this object move? Please come in fast, right? So in this case, see, you can see that two bodies A and B are applying equal forces from both the directions, right? So that means the net force acting on this object is zero. Na? So, whenever the net force acting on an object is zero, yes, very good, Anika. Whenever the net force acting on an object is zero, we say that the body is in translational equilibrium. Clear? So, F net equal to zero means translatory equilibrium. But please note it down that if net force acting on a body is zero, that does not mean that the body will be necessarily in equilibrium. Let's take this example. एक example देखिए, then you'll understand. Let's say we are having this rod, okay, which is hinged at this point. Hinged means it is like आपने वहां पे क्या किया है, एक rod लिया है और बीच में उसकी कील ठोक दी है, ठीक है। Now on this rod we are applying two forces. Uh, let's say one force I'm applying from this side, 5 Newton, and the other force I'm applying from this side, 5 Newton. What is the net force acting on this object? Anika? Anika, Ranjit, please tell, what is the net force acting on this rod? कितना net force लग रहा है इस rod पे? जल्दी से कमेंट करके बताओ। देखो 5 ऊपर से लग रहा है and 5 is acting from downward, that means net force acting on it will be 0, isn't it? Net force 0 है. But what according to you will happen in this case? Will the rod rotate or not? Even if the net force acting on this rod is 0, but still the rod will show some motion. It will start rotating in this direction, right? In anti-clockwise direction, the rod will start rotating. So that means even if net force acting on an object is 0, you can't say that the object is in equilibrium, right? But it means that the object is in translatory equilibrium, but not rotational equilibrium. So in this case, the object, the rod, will start rotating, right? So what will happen, like when we are talking about rotational equilibrium, the important thing is the net torque acting on the object should be zero. Like you don't have to study, yes, very good, Anika, you don't have to study much about torque right now, but we'll discuss the torque in the coming sections. But for now, I'm just writing about the rotational equilibrium, that a body is said to be in rotational equilibrium if the net torque acting on the object is equal to zero, right? So when we are talking about the total equilibrium of a particle, there are two conditions, right? The conditions will be that the net force acting on it should be zero for it to be in translatory equilibrium. And the second condition will be that the net torque acting on the object should also be zero. Then only you can say that the total equilibrium of the particle is there. Is it clear or not? Please tell me fast. These points are clear. So there are two conditions. Let me write it here. F net equal to zero should be there, and net torque acting on the object should also be zero. What is torque? Torque is actually the rotating effect of force. And the rotating effect of force is called torque. It is also called moment of force. Torque is also called moment of force. Clear? Yeah, nice. So let's draw some free body diagrams of the blocks. These are the blocks. Let's say the masses I'm giving M1, M2, and crystal clear. Very nice, Anika. And M3. These are the masses of these three blocks, right? And let's say these are placed over the surface, horizontal surface. Clear. And you are asked to draw the free body diagram for these masses M1, M2, and M3 respectively. Now, you all have already studied about the normal reaction force, but let me revise it once again. What is normal reaction force? The force which acts in perpendicular direction to the surface in contact is called normal reaction force. So, whenever two bodies are in contact, are in physical contact, there will be a normal reaction force in the direction perpendicular to the surface. Clear? So, okay, let's try to draw the free body diagram. I'm starting with M1. Okay, so let's see. In order to draw the free body diagram of M1, you will draw M1 like this, right? Now, what are the forces acting on this? Yes, tricolor, right? It's looking like a tricolor. That's why I made it like this. So, what are the forces? See, weight will act vertically downward direction. Clear? Earth will always pull everything towards its center, and that thing, that force is called the gravitational force, or in simple terms we call it weight, right? So weight will always act in downward direction, and that I'm marking as m1g, right? If a body is having a mass m, then weight of the body will be mg. So m1g is acting down, right? Now see, consider this thing, let's see, if only m1g is acting on this m1, then the block should move down, right? But as you can see here, the block M1 is at rest. That means M2 must be applying an upward force on this M1, right? And that upward force is called the normal reaction force. Clear? So I'm marking that normal reaction force by the name, let's say N1. Clear? And now as the body is at rest, you can say that okay, N1 will be equal to M1G. Any doubts in here? No? Now see, let's draw the free body diagram of M2. For M1, it is done. Only two forces are acting on M1. One is weight downward, mg downward, and the other thing was the normal reaction force from M2. Now, when you draw the free body diagram of M2, what will happen? Weight will act down. It always acts down, which is M2g in downward direction, right? Now, see, M1 was applying N1 to M2 in downward direction. That's why M2 applied N1 in upward direction to M1, right? देखिए, यहाँ पे M2 ने M1 पे N1 लगाया ऊपर की डायरेक्शन में, तो न्यूटन थर्ड लॉ से क्या होगा? M1 भी तो M2 पे नीचे की डायरेक्शन में N2 लगाएगा, लगाएगा कि नहीं लगाएगा? So the same thing you should mark in here, right? So यहाँ पे I'm marking N1 acting in downward direction over M2. This N1 is coming from m1. Clear है? Now see, m2 is in contact with m3. ये वाला surface contact में है, right? So m3 will exert an upward force on m2 that I'm marking as n2. This is the normal reaction force between m2 and m3. ये क्लियर हुआ या नहीं हुआ, जल्दी से मुझे बता दो. And the net force acting on m2 is also zero because this is at rest. So you can say that the net downward force should be equal to net upward force. That means n2 should be equal to n1 plus m2g, and in place of n1 you can write m1g, so this will become m1g plus m2g. This is equal to n2. You can take g common, so this will become m1 plus m2g. This is n2. This is the value of n2. Clear? Now, so the free body diagram for m2 is also clear. For m1 is also clear. Anika, is it clear to all? Is it clear to you? And what about Ranjit? Now let's draw the free body diagram for m3. Right? m3 के लिए we drew the m3 like this. Right? What are the forces acting? The obvious force, one obvious force is weight acting in downward direction, which I'm marking as m3g. Right? Now see, m3 was applying n2 on m2 in upward direction, right? So by Newton's third law, m2 will also apply n2 in downward direction upon m3, right? So I'm marking that n2 like this. Clear? And m3 is in contact with this ground surface. So the ground will also apply a normal reaction force. And that I'm marking by n3. आर दीज पॉइंट्स क्लियर? ये सारे फोर्सेस आपको समझ आए? m3 का वेट नीचे लग रहा होगा. m3 ने जो नीचे वाला मास है ग्रीन कलर वाला, उसने व्हाइट वाले पे नॉर्मल लगाया था n2 इन अपवर्ड डायरेक्शन. सो m2 भी m3 पे नॉर्मल लगाएगा इन डाउनवर्ड डायरेक्शन. तो हमने यहाँ पे ऊपर से n2 मार्क कर दिया, राइट? और वेट तो लग ही रहा था m3g. सो ये सारे फोर्सेस हमने मार्क कर दिए. नाउ m3 इज आल्सो एट रेस्ट, right? That means net force on m3 should be zero, or we can say net upward force should be equal to net downward force. So just apply the equation. Dekho, what is the net upward force? It is only n3. What is the net downward force? It is n2 plus m3g. Now put the values. What is n2? N2 is m1 plus m2g. So m1 plus m2g plus m3g, right? So we got the value of n3 as m1 plus m2 plus m3 in bracket g. Is it clear to all? जल्दी से बताओ clear हुआ या नहीं हुआ? So we got the free body diagrams, and we additionally got the value of normal reaction forces at each and every surface. Clear hai? Right? Let's do few more questions on free body diagrams. What is the question telling in this case? There is a rough plank resting on a cylinder. This is the rough plank which you can see, which is resting on a cylinder with one end of the plank resting on a rough ground. Okay, fine. Neglect friction between the plank and the cylinder. Draw the free body diagrams for both. So in this case, we have to draw the free body diagram for the cylinder as well as for the plank, right? So let's start with the cylinder, right? And we have to neglect friction between the plank and the cylinder. Okay. So let's say we have this cylinder like this. Cylinder is in contact with this ground surface, and the cylinder is in contact with this plank, right? So whenever two bodies are in contact with each other, the normal reaction force will act in the direction perpendicular to the surface in contact, right? So the ground will exert an upward force on the cylinder, right? So I'm marking this upward force on the cylinder by, let's say, n1, right? I should remove this ground surface. We should not make it, right? Then weight will also act on the cylinder in vertically downward direction, right? So I'm marking weight in downward direction and g down. Like you can just make a point like this for the cylinder, and then you can mark all the forces. So n1 is acting in upward direction like this. Weight is acting in downward direction. Let's say mass of the cylinder is m1. So M1G will act in downward direction. And see, this surface is in contact. There is a surface between the cylinder and the plank which is in contact. So the plank will also exert a normal on the cylinder in the direction perpendicular like this. Right? So marking that force like this. Let's say this normal reaction force is N2. So we have made the free body diagram. We are done with the free body diagram of the cylinder. Clear हुआ या नहीं हुआ इतना बता दो मुझे. Right? Similarly, we'll make the free body diagram for the plank also. Right? So for the plank, we have to make the plank like this as it is. ये देखो यहाँ पे हमने plank बना दिया है. ये कुछ इस तरीके से है रखा हुआ. Right? So this is the plank. अभी देखो प्लैंक का मास लेट्स से m2 है. प्लैंक का मास मैंने m2 ले लिया तो इसका वेट नीचे लग रहा होगा. वेट ऑलवेज एक्ट्स इन वर्टिकली डाउनवर्ड डायरेक्शन. सो m2g यहाँ पे हमने लगा दिया. राइट अब देखो प्लैंक was applying n2 on the cylinder. So in return the cylinder will also apply n2 on plank in opposite direction like this. Any doubts here? Clear है इतना? Right now this surface is in contact with ground. Right, so the ground will also apply a normal reaction force on the plank. Right, let's call that normal as n3. So this is the normal reaction force n3. Right, and we have to neglect the friction between the plank and the cylinder, but the question has not asked us to neglect the friction between the surface and the plank. So this surface is in contact with the ground and this surface has a tendency to slip towards right. है ना, अगर आप इसको छोड़ देंगे तो ये प्लैंक का टेंडेंसी है राइट डायरेक्शन में शिफ्ट होने का. सो व्हाट इज गोइंग टू हैपन? फ्रिक्शन विल ट्राई टू प्रिवेंट द मोशन. It will try to prevent the relative slipping between the plank and the surface. So friction will act in this direction. Right? I'm marking that force by small f. So this will be the free body diagram of the plank. Is it clear to all? जल्दी से बताओ सबको समझ आया कि नहीं आया? So ये वाला हो गया आपका FBD of plank and ये हो गया आपका free body diagram of sphere. ये दोनों पॉइंट्स आपको क्लियर हुए या नहीं हुए? जल्दी से कमेंट करके बताओ यार. Is it clear to all? Please comment fast. अनिका, रंजीत एंड whoever is watching me here, जल्दी से बताओ समझ आया या नहीं आया आप लोगों को. ठीक है, आपको क्या करना है, सिर्फ जो फोर्सेस उस पे लग रहे हैं वो फोर्सेस मार्क कर देने हैं. राइट, और हमने यहाँ पे भी कुछ नहीं किया है ना. और कुछ क्वेश्चंस करो, चलो समझ आ जाएगा. इन दिस क्वेश्चन देयर आर टू बॉल्स A and B which are like placed in such a manner as shown in the figure between two walls. है ना, and you have to draw the free body diagram for the balls. इन दोनों balls का free body diagram बनाना है. So let's say the mass of m1, like the mass of A is m1 and the mass of B is m2. ठीक है, so let's try drawing the free body diagram for m1 first. है ना, so मैं यहाँ पे एक सर्कल बनाता हूं जो कि m1 को रिप्रेजेंट कर रहा है. राइट, दिस इज फ्री बॉडी डायग्राम फॉर A. राइट, अभी देखो जहां जहां सरफेस कांटेक्ट में है वहां वहां एक नॉर्मल रिएक्शन फोर्स लगेगा. राइट, एट ईच एंड एवरी सरफेस इन कांटेक्ट देयर विल बी अ नॉर्मल रिएक्शन फोर्स in the direction perpendicular to the surface. So let's talk about this surface, this wall and the ball A. Right, so the wall will exert a normal reaction force on A in this direction perpendicular to the surface. Let's call this normal as n1. Right, mass of the body A was m1, so mg will act in downward direction like this. Right, m1g, this is the weight of the body. Now this, there is this surface also, the surface ground and of the body A. So ground will also exert an upward force on this surface. Right, let's call that normal as n2. So n2 will act in upward direction like this. Clear? Now one more surface of this body A is in contact with the body B. So the ball B will also exert a normal reaction force in the direction perpendicular to the surface. That means in this direction. Let's call this normal as N3. So this will be the free body diagram for A. There are four forces acting, three from the surfaces in contact, and one is the weight which is acting in vertically downward direction. Right? So if you are getting confused in this diagram, you better draw mass A or the body A as a point, right? एक point की तरह आप इस body A को बनाओ and then mark all the forces. Like N1 was acting in this direction, right? N2 is acting in upward direction like this. M1G is acting in downward direction like this, and N3 is acting at this surface like this. समझ आया? So that will become the free body diagram for body A. Let's try to draw the free body diagram for body B. So for that thing, I'm trying to draw a circle. Let's say this is body B, right? This is FBD for B. Clear? Now, what are the forces acting? Weight will act down. So let's say the mass is M2. So I'm marking M2G like this. Weight always acts vertically downward direction. ठीक? Then this surface of B is in contact with the wall, right? So the wall will exert a normal reaction force. Let's call this normal as we already have used up 2 and 3. So let's call it N4, right? So we have marked the weight M2G. We have marked the normal from the wall. Now this portion was also in contact of body A and body B. And now see, in while making the free body diagram for body A, we had marked that the force which body B is applying on A is N3, right? So in return, by Newton's third law, the body A will also apply this normal reaction force in opposite direction on B, right? So this normal N3 will act in this direction, right? So we have marked all the forces. There were two surfaces in contact, right? And we marked the two normal reaction forces N3 and N4. Weight was acting in vertically downward direction, so we have marked the weight M2G. Now, if you want to remove this circle, you can remove, right? No need for this. Now, this will become the free body diagram for P. So, I hope these points are clear to all how to make the free body diagram, right? If not clear, we'll do one more example. Let's say we talk about this thing. There is a ball which is hanging like this, taking support from the wall, and there is a string attached to it, and you have to draw the free body diagram for the ball in this diagram, ball in the figure, right? So again, let's try making this thing. Let's say this is the ball, right? Mass of the ball is not given. Let's assume it to be m. So m1 mg will act downward. Weight will always act vertically downward direction, right? So mg is acting in downward direction. Now this surface of the ball and wall is in contact with each other. So normal reaction force from the wall will act on the ball in perpendicular to the surface like this. Let's call this normal as n, and as there is only one normal, right? Now there is the string attached to the wall, the CB string, right? Now what is the function of a rope or a string? A rope or string always pulls, right? It can never push anything, right? So the pulling force, as we have studied already, what is the pulling force of rope called? The force by which a rope pulls is called the tension force, right? So in this case, the tension of the string will pull this mass towards this direction, and I'm marking that force by letter T, as it is the tension force. So I guess we have marked all the forces. We have marked the weight, we have marked the contact force, which is the normal reaction force, and we have marked the tension force because of the string. So this will become the free body diagram for the ball, right? So now if you want, you can erase this circle. Now this will become the free body diagram for this ball. Is it clear? Please tell me if you are having any doubt regarding this. Because see, if you have learned how to draw the free body diagram, half of the thing is done. The only thing which you require to do after that in this laws of motion chapter is to apply the equations, which is obviously like if you are done with the free body diagram, you can simply resolve the force into components and just apply the laws of motion according to, like if you are trying to find the acceleration in x direction, resolve the force components in x direction. If you are trying to find the acceleration in y direction, resolve the forces in y direction, and then write F net is equal to ma. Clear? So, okay, things will get clear. But before that, first let's learn about dividing force into its components, right? So, I have already told you this thing in so many classes. Let's say, but let's revise it again. Let's say we are having this force, or let's say any vector A, right? Which is making an angle theta with the horizontal, right? So we have studied vector addition. The triangle law of vector addition says that if we have two vectors like this, let's say this vector plus this vector, then the resultant of these two vectors will be this vector, right? So I can write in this case that A vector plus B vector is equal to C vector. Similarly, in this case with the vector A, we can write that this vector A will be equal to this vector in horizontal direction plus this vector in vertical direction. So let's call this horizontal vector as AX, horizontal component, and let's call this vertical component as AY. So what we are trying to do, we are trying to find the value of this AX and AY, right? So in this case, we're talking about force. So let me draw one more diagram which will show that a force is acting in this direction, which is making an angle theta with the horizontal, right? So this force also, as it is a vector, can be divided into two components. One is this Fx and one is this Fy. These are called the rectangular components of a vector, right? Because these components are having a 90-degree angle between them. That's why the name rectangular components, right? So what we can write? We can write that this F vector is equal to Fx vector plus Fy vector. Clear? By law of vector addition, triangle law of vector addition, right? Now in this triangle, suppose you are trying to write the value of sine theta, right? So sine theta is equal to perpendicular by hypotenuse. What is perpendicular here? Fy. And what is the hypotenuse? F. So from this you can write that Fy is equal to F sine theta. Any doubts in here? No? Right? Similarly, if you write cos theta, you will get the value as, what is cos theta? Base by hypotenuse. Base here is Fx and hypotenuse is F. So from this you can write that Fx is equal to F cos theta. Right? So that means instead of Fx you can write F cos theta and instead of Fy you can write F sin theta. तो इसको आप ऐसे समझ सकते हैं कि if you are having a force which is making an angle theta with the horizontal, that force can be replaced by these two rectangular components, right? One will be F cos theta in the direction of theta, like which is this force F cos theta in the horizontal direction, or you can say along theta, and the other force will be F sine theta in the direction perpendicular to it, right? So these are the components of this force, better call it the rectangular components, right? So like talking more about components, see if you are talking about this figure, then also you can say that A and B are the components of vector C, because you can write C vector is equal to A vector plus B vector, right? But in this case, A and B vectors are not the rectangular components because the angle between them is not 90-degree, right? But in this case, the angle between these two components was 90-degree. That's why we can call that these two are the rectangular components for the force F, right? So let's do a question on dividing force into components. Then things will get more clear to you, right? So in this question, what is it telling? It is telling that all strings are massless. Okay, then tension in the horizontal string is 30 Newton. Find weight, right? So they have told that all the strings are massless. Like generally in your ninth class, you'll get all the questions in which strings will be massless, right? Pulleys will be massless. But in my class, we'll do questions in which strings will be also having masses. We'll see what changes will happen if a string is having mass. right? You'll learn so many different things in that, right? Now see in this question, what is the question telling? That the tension in the horizontal string is 30 Newton. So this is the horizontal string. Tension is 30 Newton, right? And we have to find W if this angle is 45. So talking about the other two strings, let's say that we mark that the tension in this string is, let's say, T1, and let's say the tension in this string is T2. First, draw the free body diagram for this weight. So what is happening? Weight will act vertically down. So weight is W, so we'll mark it as W downward, right? And T2 is pulling it in upward direction. And the body W is at rest. So if it is at rest, that means F net is equal to 0 on it, right? Acceleration is 0. So that means T2 will be equal to W, net force in upward direction will be equal to net force in downward direction, right? So from here we got that T2 is equal to W. No doubts in this, right? Now see, let's talk about this point. So let me draw this point like this. If we draw the free body diagram of this point, let's see the forces. 30 Newton will try to pull it towards right? Because tension always pulls. T2 will try to pull it in downward direction, and I'm putting the value of T2 directly as W, right? And T1 will pull it in this direction. This is T1. This angle they have given as 45 degrees. So what we can do, we can divide T1 into two rectangular components, horizontal and vertical direction, right? So why we are doing that, by the way? We are doing that because see, we have this W and 30 Newton already in vertical and horizontal direction, right? But T1 is acting at some angle. So in order to make things easier, better divide T1 into its rectangular and into its rectangular components, so that we get all the forces in horizontal and vertical direction, right? So as we studied, that if we have a force F, this angle is theta, then F cos theta will come in this direction and F sin theta will come in this direction, right? So when we divide T1 into components, this component will be T1 sin 45 and the upper component will be T1 cos 45. Don't get confused that why I'm putting T1 cos 45 in up, right? See, along theta is F cos theta. In this case, this was theta. So that's why this is T1 cos theta. Now see, as this point is at equilibrium, that means net upward force will be equal in net will be equal in downward direction. Like whatever force is acting in upward direction will be equal to the force acting in downward direction. So you can write T1 cos 45 degree is equal to W, and you can write the force towards left should be equal to force towards right as the point is at rest. So T1 sin 45 is also equal to 30 Newton. So see, from the second equation, you can find the value of T1, right? And put it there in equation 1, you will get the value of W. Now sine 45 is 1 by root 2. So put the value. You'll get the value of T1 as 30 root 2, right? Now substitute this value of T1 here in first equation. What we'll get? We'll get see T1 as 30 root 2. I place a, then cos 45 is 1 by root 2. This is equal to W. So what we got? W is equal to 30 newtons, as the weight should be in Newton. It is a force, right? And suppose we were asked to find the mass, you'll get the value of mass as W by G, which is 3 kg. So mass of the body is 3 kilograms and the weight of the body was 30 Newton. So I hope whatever we studied today, everything is clear to all of you. If you're having any doubts, please mention that doubt in your comments and fill up the doubt form, right? So that in next doubt session we can clear all your doubts. So hoping that you understood everything. Please like the video. If you understood everything, please share the video with your friends and hit the bell icon so that you can get notified every time we upload any new video. Thank you so much. Let's end this class. We'll meet you in the next class. And about the next class, what are the timings and all, you will get notified once you subscribe to this channel. Everything will get uploaded here. Okay, and join our Telegram group so that in advance you can get all the timetables. Okay, so thank you so much. Have a nice day.